Welcome, dear friend, to Dreamtime Science. Imagine yourself amidst shelves of ancient books, their spines worn soft under the gentle glow of a bedside lamp. The night outside stretches quietly, stars whispering old secrets through the window. Here, in this calm nook, we invite you to drift gently into stories wrapped in tranquility and wonder. If this moment feels right, a quiet tap of the like button or a soft word shared in the comments about where you listen from would mean the world. Let yourself settle now, adjust your pillow just so, breathe in slow, even rhythms. Together we will wander softly through the twilight realms of knowledge, letting curiosity soothe the mind while sleep tiptoes closer. Whenever you are ready, let your journey begin as we turn the page together. You know, I've been thinking about something that sounds like a storybook adventure. What if you could dig a tunnel straight through the earth and just fall all the way to the other side? There's something remarkable about imagining that journey, from the crust we walk on to the mysterious core beneath, and how gravity and heat would play a part in such a wild ride. I'm excited to share some surprising truths about what would really happen if we tried. It's a mix of science and wonder that feels just right for bedtime. If this peaceful blend of science and serenity helps ease your evening, consider joining our community of gentle learners. Share your favorite moment of scientific awe in the comments. Let's prepare for tonight's journey. Find your most comfortable position, let tension float away from your body, and take 3 slow, peaceful breaths. Beneath the hush of night, when the world above grows quiet and shadows stretch long over the land, a different world stirs in the imagination, a world that lies not among the distant stars, nor across uncharted seas, but deep within the very planet upon which we stand. The notion of what lies below our feet has haunted and enchanted the human mind for centuries. To gaze at the ground and wonder, what lies beneath? How deep does the earth go? If we could tunnel downward, would we find buried civilizations, hidden oceans, monstrous creatures, or perhaps the fiery heart of the world itself? This is the journey that begins not with shovels or drills, but with dreams, stories, and the ancient, unyielding curiosity that binds us all. Centuries ago, before the age of satellites and seismic tomography, the Earth's interior was a domain ruled by myth and speculation. Ancient peoples in every corner of the world peered into cavern mouths, volcanoes, and deep wells, inventing tales to explain the darkness below. The Greeks imagined Hades, a shadowy underworld, a land of the dead below the crust of mortal existence. In Norse legend, the roots of Yggdrasil, the world tree, extended into dark, secret realms teeming with serpents and giants. The Hopi of North America spoke of ancestors emerging from the womb of the earth, while in the vast deserts of the Australian continent, stories told of rainbow serpents coiling through subterranean rivers. But as the centuries passed, the torch of curiosity was handed from the shamans and poets to the philosophers and naturalists. During the Enlightenment, the Earth's structure became a subject of earnest debate. Was it hollow, as some suggested, filled with inner suns and secret skies, or was it a solid sphere, its heart as dark and unknowable as the night sky? Theories abounded, each as wild and wondrous as the last. The English astronomer Edmund Halley, famous for the comet that bears his name, once proposed that the Earth was made of concentric shells, like a Russian Matryoshka doll, perhaps sheltering hidden civilizations within. It was into this swirling sea of speculation, myth, and burgeoning science that Jules Verne cast his literary line. In 1864, with the publication of Journey to the Center of the Earth, Verne did more than tell a story. He invited his readers to tunnel through the layers of geology and imagination alike. In his tale, the eccentric Professor Lidenbrock, his nephew Axel, and their stoic Icelandic guide Hans descend through a dormant volcano, hoping to reach the planet's very heart. Their journey is not just a descent through rock and magma. It is a voyage through the layers of human wonder, fear, and hope. Verne's vision was a wild one, and yet not wholly divorced from the science of his time. The 19th century was a period of feverish geological discovery. The first dinosaur fossils had already been unearthed, and geologists were beginning to piece together the jigsaw puzzle of stratigraphy, the study of rock layers, and what they revealed about Earth's history. The Earth, once thought static and eternal, was now understood as a dynamic entity shaped by forces both seen and unseen. In Verne's fictional world, the journey downward is an adventure of the senses. The travellers encounter vast caverns, primeval forests illuminated by the eerie glow of subterranean light, and seas haunted by monstrous creatures from a forgotten age. These were not mere flights of fantasy. They were rooted in questions that real scientists were asking. Could there be vast, hidden spaces beneath the crust? Might ancient life survive in the warmth and darkness, untouched by the surface world's changes? Even today, as we drill deep into the crust or peer into the plumes of hydrothermal vents, we find life thriving in places we once thought impossible. Yet, for all his imaginative reach, Jules Verne was constrained by the limits of 19th century science. He knew, for instance, that the deeper one goes, the hotter the earth becomes, a fact first hinted at by the miners and well-diggers of the industrial age, who reported stifling heat as they sank deeper into the ground. And so, in Verne's story, the travellers must contend with rising temperatures, though he underestimated just how quickly and fiercely the heat would rise. In reality, the journey to the center of the earth would be a journey not just through stone, but through a furnace, with temperatures and pressures that defy human endurance. As Verne's tale captured the public imagination, the idea of tunneling through the earth burrowed ever deeper into popular culture. The notion of a hollow earth, with its hidden worlds and lost peoples, flourished in the pages of pulp magazines and the reels of early cinema. Edgar Rice Burroughs sent his hero, David Innes, into the Pellucidar, a vast, sunlit inner world beneath the crust, where prehistoric beasts and ancient humans battled for survival. In the 20th century, the concept evolved yet again, fueled by the anxieties and ambitions of the atomic age. With the advent of nuclear power and the promise of new technologies, the center of the Earth became a frontier for scientific and engineering speculation. Could we, with powerful machines, drill a shaft straight through the planet's core? What would happen if we did? Some envisioned using the Earth itself as a shortcut for global travel. A tunnel from London to Sydney, perhaps, in which a capsule could fall freely, propelled by gravity to the antipode, and slowed by the same force as it approached the far side. The mathematics of such a journey are elegant and surprising. In a frictionless tunnel passing through the Earth's centre, an object would oscillate back and forth, taking about 42 minutes to traverse from one end to the other, regardless of distance, so long as the trajectory passed through the centre. The symmetry and simplicity of this solution is a testament to the beauty of physics, though the realities of pressure, heat, and the molten core render the concept an eternal fantasy. Still, the dream persists. In the 1960s, Project Moholy sought to drill through the ocean floor and reach the boundary between Earth's crust and mantle, a region known as the Mohorovičić discontinuity, or MOHO. Though beset by technical and financial challenges, the attempt was bold, a testament to the enduring human urge to dig, to probe, to descend. In Russia, the Kola super-deep borehole stretched more than 12 kilometers into the Earth, revealing layers of ancient rock, unexpected pockets of water, and temperatures that rose far higher than predicted. The Kola borehole stands as a monument to curiosity and perseverance, a needle-thin wound in the crust that hints at the vastness below. In the realm of fiction, the fascination with descending into the Earth has never waned. Films, comics, and novels abound with tales of explorers braving the unknown, battling monsters, or finding lost civilizations in the lightless depths. The Earth's interior, unknown and unseen, becomes a canvas for our hopes and fears. It is a place where the laws of nature bend, where time itself seems to flow differently, and where the past persists alongside the present. In these stories, the descent is more than a physical act. It is a metaphor for confronting the unknown, for plumbing the depths of the psyche, for seeking the origins of life and the fate of worlds. Why, one might wonder, does the idea of tunneling through the Earth exert such a powerful pull? Partly, it is the allure of the forbidden, the unseen. The surface of the planet is mapped and measured, but the interior remains elusive, glimpsed only through indirect means. Earthquakes send shock waves that echo through the mantle and core, revealing their structure in patterns of trembling. Volcanic eruptions hurl fragments of the deep onto the surface, each a message from the darkness. But to actually go there, to descend in person, this remains impossible for now, and thus endlessly seductive. There is also perhaps something more primal at work. The act of digging, of burrowing, is written into the story of life itself. Creatures have tunneled for shelter, for food, for warmth, for millennia. The first mammals, small and vulnerable, took refuge underground as dinosaurs thundered above. Even now, the earthworm and the mole, the ant and the termite remind us that there is a world below, teeming with activity, hidden from the sun. For humans, the descent can be both a return to origins and a leap into the unknown. The modern age brings new tools and new visions. Today, geophysicists peer into the planet's depths using seismic waves, gravity measurements, and the slow drift of tectonic plates. We know now that the Earth's interior is layered, a brittle crust, a viscous mantle, a churning outer core of liquid iron, and a solid inner core spinning slowly at the planet's heart. We can model these layers, simulate them, even recreate their pressures and temperatures in laboratories. But the direct experience, the tactile, immersive journey that Verne imagined, remains forever out of reach. And so we dream. We write stories, draw maps, build models. We send sound waves and sensors, stretch drills to their breaking point, and gaze in wonder at the fragments that surface. Each discovery is a clue, a piece of a puzzle that spans billions of years. The more we learn, the more our questions multiply. What secrets lie locked in the mineral grains of the deep mantle? What strange forms of life might lurk in the warmth and darkness, nourished by chemical energy rather than sunlight? Could the movement of magma and metal in the core hold the key to the planet's magnetic field, and thus to the shield that protects all surface life from the sun's fierce winds? The fascination is not merely scientific, nor entirely poetic. It is a blend of both, a fever of curiosity, a hunger for revelation, a yearning to know not just where we stand, but what lies beneath. The journey to the center of the earth is, in the end, a journey into ourselves, into the depths of our own imagination and wonder. As you lie in the stillness of night, you might picture yourself at the rim of a great volcanic crater, looking down into the abyss. The stones beneath your feet are warm. The air carries the scent of sulfur and ancient smoke. Somewhere in the darkness below, mysteries beckon. Stories waiting to be told. Riddles to be unraveled. The descent has barely begun. The tunnel stretches into shadow, promising both peril and discovery, and the echo of ancient footsteps can almost be heard. Somewhere far below, the earth stirs in its sleep, and above the stars look on, silent and watchful, as the journey continues downward ever deeper, toward the molten heart of the world. Beneath your feet lies a world both familiar and unfathomably alien, a sequence of hidden kingdoms layered one atop another, each stranger and more hostile than the last. The crust upon which all life's dramas are staged is but a wafer-thin veneer, a brittle skin that floats atop the restless, molten heart of the planet. Tonight we let our minds drift downward, following an imaginary shaft as it bores into the earth, a tunnel through time, ambition, and the very limits of human understanding. Suppose for a moment that you could step into a capsule at the edge of a vast construction site somewhere on a quiet meadow or crowded city street. You sit back, and the mechanisms around you whir softly. The tunnel's mouth yawns, swallowing your vessel in a hush of anticipation. The light fades and the air grows cool as you descend, leaving behind the surface and its familiar chaos. Very quickly you find yourself moving through the upper crust, a tangled mosaic of rock, gravel and clay, remnants of ancient seabeds, volcanic flows, fossilized forests, and the shattered detritus of continents that have drifted, collided, and sundered over 1 billion years. Geologists, those patient detectives of stone, have mapped only the shallowest layers with any confidence. The crust's thickness varies from a few kilometers beneath the oceans to up to 70 beneath some mountains, a span that is both vast and minuscule compared to the planet's true girth. Within this brittle shell, we have eked out our existence and, with considerable effort, have learned to pierce it, just barely. The deepest hole ever drilled by human hands, the Kola super-deep borehole in northwest Russia, reached a depth of 12,262 meters, just over 12 kilometers, a hair's breadth, a mere scratch upon the Earth's skin. There, the drill met temperatures and pressures that defied expectation, and the rock grew plastic and unyielding, as if the planet itself were pressing back against our curiosity. Your imaginary tunnel, however, ignores such limits. It bores downward, deeper and deeper, through increasingly ancient and distorted strata. In the upper reaches, you might notice pockets of water trapped in porous rock for millions of years, briny, sluggish reservoirs that glimmer with the chemical traces of vanished seas. Descend further, and the rocks become harder, crystalline, and contorted by the immense forces of tectonics. Here, in the lower crust, minerals are crushed into new forms, their lattices warped by heat and pressure. The air would long since have vanished, replaced by a suffocating, oppressive darkness and searing heat. In this imagined journey, we must pause and consider the sheer audacity of the task. To dig a tunnel through the earth is to challenge not only stone and gravity, but the very nature of matter itself. The deeper you go, the more the weight of rock above you presses down, increasing the pressure relentlessly. At the bottom of the Kola borehole, the pressure is nearly 400 times that at the surface, and the temperature has soared past 180 degrees Celsius. The rock behaves strangely, no longer brittle and familiar, but ductile, slowly flowing and squeezing inward like warm wax. No human could survive here, and no material we know can persist indefinitely under such relentless assault. Yet, in our thought experiment, the tunnel holds. Down you plunge, leaving the crust behind to enter the mantle, Earth's great and restless engine room. The mantle, contrary to the old image of a sea of molten lava, is mostly solid, yet it moves, creeping imperceptibly over eons, driven by the heat that seeps upward from the planet's core. Here, minerals are transformed by crushing pressure. Olivine, the green gemstone of the upper mantle, slowly reshapes into denser forms, their very atoms forced into new arrangements. The temperature rises relentlessly, reaching 1,000, then 1,500 degrees Celsius. Rock glows with internal heat, not molten but softened, able to flow with the patience of geology. For all our cleverness, we have never sent a probe into the mantle, let alone a person. The closest we have come are the deepest mines and boreholes which barely penetrate the crust. We know the layers below only through indirect means, the echoes of seismic waves from distant earthquakes, which change speed and direction as they pass through different materials. These ghostly signals have revealed that the mantle is not uniform. It is riddled with plumes and currents, vast, slow rivers of rock that rise and fall, driving the drift of continents and the birth of volcanoes. If your tunnel were real, it would pass through regions where rock moves over millennia, warping and swallowing anything in its path. Technology as we know it cannot withstand these conditions. The drill bits and casings that serve us in the upper crust would melt or deform in hours. Electronics would fail, metals would weaken, and any attempt to keep a shaft open would be thwarted by the creeping plastic mantle which would close around the tunnel like a fist. Even if we could keep the tunnel open, there is the question of heat. The deeper you go, the more the temperature climbs until it becomes impossible to cool the walls. Any machinery, any capsule, would require extraordinary insulation and cooling, systems that at present exist only in the fevered imaginations of science fiction. Let us suppose, for the sake of the dream, that these obstacles are somehow overcome. Your capsule, protected by unearthly materials, continues its descent. After nearly 3,000 kilometers, you reach the boundary between mantle and core, the greatest of the planet's hidden frontiers. Here, seismic waves change abruptly, as if striking an unseen wall. The rocks above give way to something altogether different, a sea of liquid iron and nickel, swirling and churning, its movements generating the magnetic field that shields us from the fury of the sun. This is the outer core, a place beyond anything we can truly imagine. The pressure here is staggering, 3.5 million times that of the surface. The temperature rivals the surface of the sun, upwards of 4,000 degrees Celsius. Iron, which would shatter at room temperature, flows here like water, convecting slowly in great looping currents. If your tunnel somehow survived the journey so far, it would now be surrounded by a liquid metal ocean, a realm more hostile than any found on the surface of the planet. Here, too, our knowledge is but a shadow. We infer the properties of the core from the way seismic waves pass through it, and from the requirements of Earth's magnetic field, but no human instrument has ever touched this world. The core is, in a sense, the last great terrestrial wilderness, untouched, unmeasured, and perhaps forever inaccessible to direct exploration. And yet, the journey is not over. Dive further, and after another 2,000 kilometers, you reach the very heart of the planet, the inner core. Unlike the outer core, this region is solid, forged by pressures so immense that iron cannot remain liquid. Here, in the planet's secret heart, temperatures may soar past 6,000 degrees, yet the iron remains crystalline, its atoms locked in an orderly array. Recent studies suggest that the inner core may be divided into layers, each with subtly different properties, and that it may even rotate at a slightly different speed from the rest of the planet, a great iron bell tolling in the dark. Even if your capsule could somehow survive this descent, what would it find at the very center? Gravity, which presses down so mercilessly at the surface, would vanish here. The pull of all the surrounding mass would cancel out, leaving you weightless, adrift in a sea of unimaginable heat and pressure. Light would be unknown here, and the silence would be absolute, a silence not merely of sound, but of movement and life, a place untouched by wind or weather or the slow grind of erosion. The center of the earth is a place of paradoxes, unimaginably hot, yet eternally still, dense beyond reckoning, yet nearly weightless, the engine room of the planet, yet forever hidden from view. The fantasy of a tunnel through the earth is ancient, but the realities are daunting beyond reckoning. The obstacles are not merely technical, but fundamental, a matter of physics, chemistry, and the very properties of matter under extreme conditions. The rocks would flow, the metals would melt, and the pressures would crush any structure we could build. Even if we could solve the problems of heat and pressure, there remains the issue of gravity. As you descend, the weight of the overlying rock would become almost intolerable, and yet, paradoxically, as you approach the center, gravity would diminish until at the very core it would vanish altogether. The tunnel, if it somehow survived, would be a place of shifting forces, a gradient from the familiar to the utterly alien. Yet for all these barriers, the idea of a tunnel through the earth continues to haunt our imaginations. It is the ultimate expression of curiosity, a desire to see what lies beneath, to connect distant places, to master the very substance of the planet. In fiction, the tunnel is a portal, a passage not just through space, but through time and understanding. In reality, even the effort to pierce the crust has taught us much about the limits of technology, the mysteries of the deep earth, and the sheer scale of the forces at work beneath our feet. There is poetry in the attempt, even if the goal remains forever out of reach. Each drilling project, each seismic survey, each leap of theoretical imagination brings us a little closer to understanding the world beneath us. The crust and mantle, the outer and inner core, these are not merely inert layers, but active dynamic realms, shaping the surface we inhabit in ways both subtle and profound. Volcanoes, earthquakes, the drift of continents, these are the outward signs of the planet's internal restlessness, the echoes of processes that began billions of years ago and will continue long after we are gone. Your tunnel, though fantastical, is a mirror of our longing to know, to explore, to connect. It is a metaphor for all the ways in which we seek to bridge the gap between what is seen and what is hidden, between the known and the unknowable. We may never build such a passage, but in striving to understand the challenges, we discover not just the secrets of the earth, but the nature of our own curiosity. As your imaginary capsule lingers in the depths, suspended between the crushing mantle and the churning core, you might find yourself wondering, if we could master these extremes, if we could truly bore a path from one side of the planet to the other, what would it reveal? Would we find new forms of matter, new laws of physics waiting to be discovered? Or would we find, as so often happens in science, that the journey itself is more important than the destination? The tunnel remains unfinished, a question carved into the fabric of the planet. It beckons us onward, not with the promise of easy answers, but with the allure of mystery. Somewhere far above, the surface world spins on, oblivious to the wonders and dangers lurking below. But here, in the dark and the heat, the earth keeps its secrets, waiting for the next bold question, the next impossible dream. And so, as you drift in the imagined stillness at the heart of the world, the next chapter awaits. The story of what might happen if one could, against all odds, emerge on the other side, if a tunnel through time and stone could deliver you into the unknown. Beneath our feet, the world grows denser and hotter, each stratum a record of tumult and time. Yet as creatures of the surface, we stand forever at the boundary between what we can touch and what we can only imagine. The crust is thin, cracked and broken in places, a mere eggshell compared to the vast, uncharted realms below. For thousands of years, humankind could do little more than speculate, peering into cavern mouths and volcanic vents, collecting rocks and minerals cast out by the earth's slow convulsions. The rest, the overwhelming majority of our planet's substance, was left to myth and wonder. But wonder, when persistently pursued, becomes inquiry. And so the story of how we have come to know the unreachable heart of our planet is one of both imagination and ingenuity. Tonight, let us allow our thoughts to drift down through the crust, following the slender threads of evidence that scientists have spun across the centuries. The tools of the trade are subtle and ingenious, for the earth guards her secrets jealously, and only with patience and cleverness may we hope to glimpse her inner workings. Our journey begins with a tremor, a shudder that runs through the ground, felt in the soles of your feet or the trembling of a window pane. Earthquakes, for all their destructive power, are among nature's most informative messengers. When tectonic plates grind or slip, they release pent-up energy as seismic waves, which ripple outward in all directions. These waves are the language of the deep earth, and by learning to interpret them, scientists have built a map of the unseen. There are two main types of seismic waves, each with its peculiarities and gifts. The first, called primary or P waves, are compressional. They travel as pulses of pressure, squeezing and releasing the material they move through, not unlike sound waves pulsing through air. P waves are fast and versatile. They can move through solids, liquids, and gases alike. The second type, secondary or S waves, are shear waves. They move material side to side, perpendicular to their direction of travel, much as a shaken rope sends a ripple down its length. S waves are slower than P waves, and crucially, they cannot travel through liquids. When an earthquake occurs, seismometers stationed around the globe spring into action, recording the precise arrival times and strengths of these waves. The first jolt at a distant seismometer is always the P wave, racing ahead, followed by the S wave, lagging behind. By comparing the time differences between stations, some close, some far, scientists can triangulate both the location of the quake and the properties of the materials the waves have traversed. But the story deepens. As seismic waves travel through the Earth, they encounter boundaries, places where the composition, density, or state of matter changes abruptly. At each boundary, some energy is reflected back, and some is refracted, bending along a new path. It was through careful analysis of these echoes and deflections that geologists first intuited the existence of the Earth's internal layers, the thin crust, the solid yet slowly flowing mantle, and the dense core at the planet's center. One of the earliest and most elegant discoveries came from studying the apparent shadows cast by seismic waves. In 1906, the Croatian seismologist Andrija Mohorovičić noticed that earthquake waves suddenly sped up at a certain depth beneath the continents, suggesting a change in material properties. This boundary, now called the Mohorovičić discontinuity, or MOHO, marks the base of the crust. A few years later, in 1914, Benno Gutenberg observed that S-waves failed to appear at seismometers located more than about 104 degrees from an earthquake's origin. S-waves, remember, cannot travel through liquid, so their absence pointed to a vast liquid region beneath the solid mantle. This shadow zone revealed the existence of the liquid outer core. Later refinements by Inge Lehmann, a Danish seismologist, showed that faint P waves reappeared in places they should not, indicating reflections from yet another boundary. Within the core itself lay a solid inner sphere, the inner core, encased in a sea of molten iron. In this way, by listening to the whispers of the Earth's convulsions, we have sketched out a basic portrait of its structure. Seismology is a science of inference, a discipline where patience and pattern recognition yield insights from the most transient of signals. Each earthquake, whether large or small, becomes a probe, a natural experiment, repeated countless times, all across the globe. But seismology is not the only tool at our disposal. Human curiosity is not easily satisfied with indirect glimpses, and so we have sought to reach further, to touch directly what lies below. The most ambitious of these efforts have taken the form of deep drilling projects, engineering feats that push the limits of material science and endurance. Perhaps the most famous of these is the Kola super-deep borehole, begun by Soviet scientists in the 1970s on the remote Kola Peninsula near the Arctic Circle. For decades, teams of engineers and geologists toiled to drive a slender shaft ever deeper into the crust. Problems abounded. Rocks grew hotter and more plastic than expected, threatening to swallow drill bits and warp equipment. Temperatures soared to nearly 180 degrees Celsius at the deepest levels, far above initial predictions. Yet by 1989, the Kola borehole had reached a staggering depth of 12,262 meters, over 12 kilometers, the deepest artificial point on Earth. To put this in perspective, if Mount Everest were dropped into the hole, its summit would still be more than a kilometre below the surface. From the dark core of the borehole, scientists hoisted up drill cores, slender cylinders of ancient rock, each a time capsule from a world unseen. These samples revealed surprising features. Pockets of water trapped within crystalline minerals, signs of microbial life persisting kilometers below the surface, and ambiguous boundaries between what had been classified as distinct geological layers. The crust, it turned out, was less like a layer cake and more like a swirled, marbled confection, full of folds and faults, interleaved with veins of long-cooled magma. Despite its triumphs, the Kola borehole was ultimately defeated by the relentless heat and pressure of the deep earth. The project was abandoned, the shaft capped and left to history. No human-made hole has ever come close to matching its depth, and even at Kola's greatest extent, we had barely scratched the crust, less than a third of the way through the continental shell, a mere pinprick in the planetary scale. Other drilling projects have sought different goals, probing the ocean floors, which are thinner than continental crust, or targeting active fault zones to study earthquake mechanics. The Integrated Ocean Drilling Program, an international effort spanning decades, has sampled rocks from the mid-ocean ridges and subduction zones, bringing up evidence of hydrothermal vents and the cycling of elements between crust and mantle. Each core, each fragment, is a direct testimony from the underworld, evidence to be weighed against the inferences of seismology. Yet, as far as direct sampling goes, we remain surface dwellers. The vast majority of the Earth's mass lies beyond the reach of even our boldest drills. The mantle, extending thousands of kilometers below, is tantalizingly close in a cosmic sense, yet forever out of reach. The core, nearly 3,000 kilometers beneath our feet, may as well be on another planet. So we turn to other methods, ingenious experiments that use the properties of matter and energy as our guides. One line of evidence comes from the study of meteorites, those fragments of other worlds that occasionally rain down from space. Many meteorites are thought to be remnants of the early solar system, composed of the same primordial materials that form the Earth. Some, called iron meteorites, are believed to be the shattered cores of ancient planetesimals, differentiated bodies whose heavier elements sank to the center under gravity. By analyzing their composition, rich in iron and nickel, with traces of rare elements, scientists infer that our own planet's core is likely similar, a sphere of dense metal formed in the earliest epochs of the solar system. Another window into the depths is opened by the study of gravity and magnetism. The Earth's gravity field is not uniform. It wobbles and dips in response to variations in the underlying structure. Satellites in orbit map these subtle changes, revealing mass anomalies, places where the crust is thick or thin, where dense materials lurk beneath the surface. The planet's magnetic field, too, is a clue. Generated by the slow churn of molten iron in the outer core, the geomagnetic field is a living, shifting thing. Its reversals and wanderings, recorded in the magnetized minerals of ancient rocks, provide a kind of time-lapse portrait of the core's restless movements. Even neutrinos, those elusive, nearly massless particles born in nuclear reactions, have been pressed into service. Deep underground, in vast tanks of ultra-pure water or scintillating fluids, physicists count the faint flashes of light produced when a neutrino interacts with an atom. Some of these neutrinos originate in the radioactive decay of elements within the Earth itself. By measuring their flux, scientists hope to estimate the heat flowing from the interior, and thus the abundance of radioactive materials hidden below. Laboratory experiments, too, play their part. In high-pressure chambers called diamond anvil cells, scientists compress tiny samples of rock to pressures mimicking those found deep in the mantle. By heating them with lasers or electric currents, they observe how minerals change, melt, or rearrange their crystalline structures. These experiments reveal, for example, the transformation of olivine, a common mantle mineral, into denser forms like wadsleyite and ringwoodite, transitions that help explain the layering detected by seismic waves. Still more dramatic are the shock experiments, in which samples are subjected to sudden, immense pressures by the impact of high-velocity projectiles or the detonation of explosives. For a fraction of a second, the interior of the sample reaches the conditions of the lower mantle or even the core, and scientists measure how its properties change. In this way, the laboratory becomes a miniature planet, a stage on which the drama of the deep Earth is played out in microcosm. Each of these tools, seismometers, drills, satellite surveys, meteorite analyses, high-pressure experiments, offers a different perspective, a separate line of evidence. None alone can tell the whole story. It is only by weaving them together, by comparing predictions and observations, that scientists can assemble a coherent model of the planet's interior, yet mysteries remain. The precise composition of the core, the exact distribution of heat sources within the mantle, the nature of the boundary between the solid and liquid core, these are questions still fiercely debated in scientific circles. New techniques are always being devised, new instruments built, ever finer measurements taken. The Earth, for all our efforts, remains an enigmatic companion, her innermost secrets only partially revealed. As you drift toward sleep, let your thoughts linger on these distant realms, the tunnels and shock chambers, the ocean floor cores and seismic echoes. The pursuit of knowledge is a kind of journey, not always linear, often fraught with false turns and surprises. For every layer we penetrate, another lies beyond, waiting to be unveiled by some future explorer's cleverness. And so, with the tools of science in hand, we stand poised at the edge of the unknown, ready to listen to the tremors, the signals, the faint, persistent clues that rise from the world beneath our feet. And still, there is more to the story, a deeper question. What does the restless heart of the Earth mean for us, here on the surface? For even as we probe and measure, the living planet shapes the world we know, and the story of its interior is not only one of distant realms, but of forces that ripple outward, connecting the hidden depths to the fragile lands where we dwell. Beneath our feet, the world is layered in shadow and silence. The crust on which we tread is but a fragile shell, a veneer so slight when set against the churning immensity below that it hardly seems credible how much of our history, our cities, our stories depend on its steadfastness. Yet, when we consider the notion of tunneling through the earth, of piercing that protective rind and delving downward, layer by layer, toward the unreachable heart, we reveal something not merely about the planet, but about ourselves. For the dream of the tunnel is not a practical dream. It is not born from the common need to travel or to connect distant lands. The idea of boring a shaft from one pole to the other, or from your garden to the Antipodes, is an extravagance, an impossibility. Yet it persists, returning in fables and thought experiments, in children's questions and engineers' daydreams. It is a dream that clings to us, persistent and luminous, as though in contemplating the earth's depths we might come closer to understanding our own. When we gaze up at the night sky, we feel the vastness of the cosmos. The stars wheel overhead in cold splendor, their distance both humbling and exhilarating, but the surface beneath us is just as mysterious, just as unreachable in its own way. Our curiosity is a restless flame. It turns outward to the galaxies, but also inward, downward, seeking the roots beneath the tree as much as the fruit in its boughs. The urge to tunnel through the earth is the mirror of our urge to travel to the stars. Both are quests for contact with the unknown. Both are attempts to map ourselves against the infinite. To tunnel is to journey into darkness, to confront the unknown, not as a distant point of light, but as an enveloping mystery. The earth, after all, is the first unknown any of us encounter. Its substance is the substance of our own bodies, its minerals the salts in our blood, its cycles the rhythm of our days and seasons. Yet how little we know of it. The deepest mines, the boldest boreholes, these are pinpricks, scratches upon a vastness that swallows sound and light alike. And so the fantasy of tunneling through the planet becomes a kind of parable. It is a story about human curiosity and the limits, sometimes physical, sometimes intellectual, that curiosity inevitably meets. When we imagine digging straight downward, we imagine a confrontation, not just with rock and pressure and heat, but with the boundaries of knowledge itself. The surface of the earth is a palimpsest, written and overwritten by the passing of millennia. Each layer of soil records an epoch, the dust of ancient forests, the volcanic ash of forgotten eruptions, the pollen of vanished plants. In this sediment, we read the story of life and death, of continents drifting and seas vanishing. But as we penetrate deeper, the writing becomes harder to decipher. The language of the rocks grows older, more enigmatic, until it ceases to be a record of life and instead becomes a record of the earth's own slow, inhuman processes. As we imagine our tunnel sinking further, we encounter the mantle, a realm so alien that its very substance is in flux. Here the rock flows, though so slowly that it seems frozen to any mortal observer. The boundaries blur, not just between solid and liquid, but between the known and the unknown. What secrets are locked within those vast volumes of olivine and peridotite? What stories would the minerals tell, if only we could listen? It is in these depths that we confront the limits of our senses. We cannot see, not even with the sharpest eye. We cannot hear, for sound is muffled and lost in the unyielding stone. We cannot touch, for the pressure would crush us, the heat incinerate us. Our instruments become our proxies, our delicate extensions, but even they can only go so far. The deepest hole ever drilled by human hands, the Kola superdeep borehole, reached just over 12 kilometers, less than a fingernail's depth, in a planet that stretches nearly 13,000 kilometers from surface to center. Yet even that shallow wound revealed wonders: ancient water, trapped for eons, microfossils of bacteria pressed into rock 1 billion years old, unexpected changes in seismic velocity hinting at mysteries yet unsolved. Each discovery was a question as much as an answer, a signpost pointing further into the darkness. The impossibility of the tunnel, its sheer physical impracticality, does not diminish its allure. In fact, it sharpens it. For in contemplating what cannot be done, we learn what it is we truly wish to know. Why should we long to see the core, to touch it, to stand in the center of the world? What would we hope to find there, at the terminus of all roads and all descent? Perhaps, at some level, we are searching for origins. The core is the seed from which the planet grew, the engine of its magnetism, the heartbeat that keeps the compass true and the auroras dancing at the poles. To reach it would be to touch the primeval, to place our hand upon the pulse of creation. But we are also always searching for connection. The tunnel is a line that links all that is above with all that is below. It is a thread, a conduit, a path. In the ancient myths, the underworld was a place of secrets and transformation, a realm where heroes journeyed not for conquest but for insight. To travel downward is to journey inward, to explore the depths not just of the earth but of the self. There is something archetypal in the descent. It echoes in the stories of Orpheus and Inanna, in the labyrinths of Crete and the spiral passages of tombs. The journey into the dark is a rite of passage, a confrontation with shadow that promises, if not answers, then at least understanding. Our science, too, is a kind of journey. Each hypothesis is a shaft bored into the unknown, each experiment a lantern lowered on a trembling string. Sometimes the light reveals only stone, stubborn and mute. Sometimes it glints on something unexpected, a fossil, a crystal, a clue. Always there is the temptation to dig deeper, to press onward, to ask what lies beneath the next layer. Yet science is also an act of humility. The tunnel is never straight. The passage is never easy. For every meter gained, there are 1,000 obstacles, heat, pressure, uncertainty the stubbornness of the world and the limits of our own endurance, we are reminded again and again that the earth is not ours to command. Its secrets are not freely given. Still, we persist. We sink boreholes, we map seismic waves, we send neutrinos and muons streaming through the planet, hoping to catch a whisper of what lies beneath. Our curiosity is patient, enduring. It adapts to disappointment, feeds on partial answers, grows in the face of adversity. The impossibility of the tunnel does not defeat us. It inspires us. It teaches us the value of questions, the grace of not knowing. As we consider this impossible journey, we might reflect on the paradoxes it reveals. To dig downward is, in a sense, to reverse the trajectory of our evolution. Life began in the depths, first in the sea, then perhaps in the mineral pores of oceanic rock, where the chemistry of the earth mingled with the chemistry of water to spark the first metabolism. From there, life rose upward, onto the land, into the air, toward the sun. Our own story is one of ascent, of emergence from the dark into the light. Yet here we are, compelled to look back, to turn inward, to seek the source. There is a kind of symmetry in this, a balancing of journeys. The tunnel is not an escape from the world, but a return to its beginnings. It is a way of asking where we come from, and thus by implication where we are going. In the end, the fantasy of tunneling through the earth is a testament to our restlessness. It is evidence of a mind that cannot be content with surfaces, that longs to know what is hidden, that seeks to bind together the disparate realms of experience. We are perhaps the only creatures on this planet who ask such questions, not because the answers are useful, but because they are beautiful. The tunnel is a metaphor, but it is also a challenge. It asks us to consider the limits of our knowledge, and to accept them not as failures, but as invitations. For every mystery that remains unsolved, there is the possibility of wonder. For every boundary that cannot be crossed, there is the chance to imagine what might lie beyond. And so, as we lie in darkness, listening to the slow turning of the earth beneath us, we might think of all the tunnels that have never been dug, all the journeys that remain impossible. We might picture the molten rivers of the mantle, the iron crystal at the core, the sheer weight of stone and silence pressing upward toward our feet. We might feel in the hush the ancient, patient presence of the planet, the comfort of its gravity, the pulse of its heat. It is not the answers that matter most, but the questions, the act of asking, the willingness to wonder, the courage to face the unknown. These are the gifts the earth gives us, gifts born in darkness and pressure, in the slow alchemy of rock and time. Our ancestors looked up at the sky and saw mystery. They looked down at the ground and saw sustenance. But now we know that the ground is as mysterious as the stars, and that sustenance is not only a matter of food and shelter, but of meaning and connection. The earth is not merely a platform for our lives. It is a participant in them, a silent companion, a source of endless fascination. The fantasy of the tunnel is a reminder of how little we control and how much we yearn. It is a dream of completion, of touching both ends of the world at once, of uniting what is separated by space and time, but it is also a recognition of our own smallness, our own fragility, our own dependence on the crust that shields us from the fires below. As we ponder these things, the night deepens, the world grows quiet, the questions linger, unresolved, like echoes in the dark. Somewhere, far beneath, the mantle moves, the core spins, the planet breathes in its slow geological rhythm. Above, the stars wheel onward, indifferent and eternal. Between these immensities, above and below, known and unknown, we find ourselves, curious and unceasing, forever tunneling, forever peering into the darkness and wondering what it might reveal. The earth keeps its secrets for now, but it also keeps us, and in that keeping we discover not just the mysteries beneath our feet, but the mysteries within our own hearts, waiting, patient, unending, for the next question to be asked. As our journey through the depths of the earth gently drifts to a close, like a comet tail fading into the hush of space, we are left to wonder at the mysteries beneath our feet and the dreams they inspire. Let your thoughts slowly settle, like stardust falling softly through the night, and return soon for more dreamtime tales that carry you beyond the horizon of imagination.